try to calculate some shoreline change statistics, maybe area change, okay, shoreline change envelope, net shoreline movement, EPR, and linear rate regression rates, and weighted linear regression rate. Okay, so you will see how it is done using QGIS. Okay, so to start with the basics, let's first understand what exactly your shoreline is. Okay, so basically your shoreline describes the edge of the shore, or what is shore? The stretch of dry land that is right next to the body of the water. Okay, for example, if you will see here, so this is the dry stretch of land next to the water body. And of course, this shoreline keeps on changing with your low tides and high tides. Okay, so you see shore, the land along the edge of the sea, lake, or wide river. Okay, and essentially the shoreline is where the beach ends. The precise position of shoreline can change depending upon the tides. Okay, the position of your high tide and low tide is available in QGIS. Okay, for shoreline change analysis. So there are so many tools. So QGIS, as we have seen in this 1 month training session, okay, in this 1 month stretch of time, that QGIS is no less than its, you can say, the licensed counterparts. So in the same way, your ArcGIS, in ArcGIS you have one add-on which is called Digital Shoreline Analysis System, DSAS. Okay, so this DSAS in ArcGIS, it helps you in shoreline change analysis. Okay, it helps you in the similar thing that we are going to learn today, but here you have QSCAT. Okay, so this QSCAT is an open source plugin for QGIS. Now here we have a plugin for doing the same analysis that we can do, that we could have done when we are using ArcGIS. Okay, but right now we do not have access to ArcGIS, so let's find something in QGIS. Okay, so it is designed to facilitate shoreline change analysis. And with QSCAT, it enables users to compute shoreline changes statistics such as shoreline change envelope. We will see what these exactly are and all these things. Additionally, it also calculates the length and area of accreting, stable, and eroding coastal segments. Okay, so this is the link in which you can go directly and check their manual. Okay, even after this training, you can directly go there and just have a look how exactly it works and how it was developed. Maybe in future, if you work as a developer, you can also contribute to these free resources. Okay, so this tool includes features for forecasting, also for the forecasting future shoreline positions. Okay, so based on the data that we provided, we can forecast our future shoreline positions, automating repetitive tasks and visualize results directly on the map for easy interpretation. QSCAT generates comprehensive summary reports, making it an invaluable resource for environmental scientists, coastal managers, and GIS professionals interested in understanding and managing shoreline dynamics. Okay, so this is what exactly you have in QGIS when you want to work for shoreline change analysis. Okay, so what are the requirements? So the basic requirement is a shoreline layer. Okay, and that to be at least you should have 3 shoreline layers. Okay, at least 3 shoreline layers you need to have to work with this particular plugin. Okay, and of course these 3 shorelines will be from different time period. However, due to tides, the shoreline isn't always the same as the waterline that we see in our in our satellite images. The shoreline can vary between low tide line and the high tide line. So now when you have the shoreline data, shoreline layers from different years, let's say 2005 and 2015 and 2024. Okay, now you have to, when you want to work with this plugin, you have to merge them all together. So if you have shoreline vectors for each year stored in different layers, you need to combine all those layers into a layer. So after merging, each feature in the shoreline layer should contain the necessary information for each shoreline, including the shoreline date, in which the date, the date in which you have collected it, and the uncertainty. Okay. Next requirement is your baseline. So baseline is another important input data. A vector constructed that is parallel to or at a certain distance from a shoreline. Okay, so baseline will act as your let's say a reference from which you will calculate all the things. Okay, you will calculate this shoreline changes. among different shoreline layers. So a baseline is a starting point that can be onshore, offshore, or midshore. Okay, it depends upon your study area where you want to take it. Okay, so it's a reference state. Let's say you want to take your low tide line as your baseline. This way, you have to find out what exactly suits your, what suits the baseline. Okay, what exactly forms the baseline. So shoreline change, okay, we will talk about them later when we are there in our work. Okay. So when I started working this plugin, I started collecting the data. Okay. Now you need to have, as I said, you need to have at least 3 shoreline data. Okay. So the best way to collect your vector data, or let's say digitize your vector data from the historical time, okay, is to go to your Google Earth Pro. Okay. You go to your Google Earth Pro, and there you have the option of collecting your historical data. Okay. So in Google Earth Pro, what you do, you go to view. Okay. And yeah, you have the historical imagery. Okay. So click on this historical imagery. And here you see, you will get a time scale from 1984 to 2024. Okay. So if you will zoom in, so I have created this data. Okay. I'll just switch this off from now. Okay, so how I collected the data, I'm just giving you a reference. Of course, you can, if you have topo sheets from the older areas, that will also help you. Okay, or older years, okay, that's going to help you. Now, so you see when I zoom in, so at different zoom level, you have different uh, images for different time interval. Okay, and there is one more way of getting the historical image. So I have shared this KMZ file with all of you, US Army maps. Okay, version 17.kmz files. Okay, so when you open this in your Google Earth image, you will see these sort of grids, these grids here. Okay, so how it is useful for you? If you're working with historical data, you can definitely go with them as well. Okay. So if I want so I want to collect some topo sheet for this area, what I'll do, I'll click on this one. Okay. I'll click on this map. Okay. Let's wait for some time and it will upload some map for us. Yeah. You see, this is the topo sheet that we have got. I think this is from 1950s or something. Yeah, 1951. Okay, so this is the topo sheet from 1951. Okay, or 1954. It is compiled in 1954, and you can get your coast or shoreline from, if you want the data for, let's say, 54, you can collect your data from here as well. Okay, but this is not georeferenced. Mind it that this is not georeferenced. What you have to do, you have to get this data, you have to save this data in your computer. Okay, you have to download it and then georeference it and then digitize this shoreline in QGIS, and you know how to do all these steps. Okay, so I'll go to this, you can go to any of the browser it is showing. Okay, and from there you can download it, right? I'll go back to Google Earth. So this was for this area, and if you want the same data for this area, you can go to this option number 2 here. So after having the data, you need to go to QGIS, of course. Okay, so here, first of all, what we need a plugin. Okay, so I'll go to plugin, click on manage and install plugin. Okay, so let's go to all and let's check its settings. Okay, so as I said, this is your experimental plugin. Okay, so this is your experimental plugin. So whenever you have some experimental versions, so you have to go to settings and click on the show also experimental plugins. Okay, so otherwise, if it is not checked, then you won't be able to see this particular plugin in your in the list. Okay, so I have given you the zip file from where you can install this plugin. Okay, so let's go to our zip file, and this was the plugin that I've shared with all of you. Okay, so it is successfully installed, and then close it. Okay, and you will find this sort of icon here. Okay, and you will also find it under plugins. If you have activated your, let's say, okay, sorry, plugins toolbar, okay, you can find that in your project toolbar. Okay, and otherwise you have it here, right? Just click on it and let's open it. Open our new folder. Okay, so first start with saving your project. Okay, and shoreline change. Let's give it a name. Click on save. Okay, now we have our project home and we can load our layers. Okay, and before that I want to get my base map so that I can see where my study area is falling. Okay, so now I have given you these all these KML files, no, not KML files exactly. I have given you this geo package, okay, because it has all the modified layers that we wanted to work with for 2004, 2009, and all these 4 files I have given you. And this I have created using the same way I told you in Google Earth Pro, okay. And I don't know if you know how to digitize in Google Earth Pro. I forgot to mention that. Okay, so how you can digitize it? You can use this add path option, okay, and give it some name. Let's say I'm just putting it as untitled path and just use this here. Okay, I'm just creating it somewhere here. Okay, just use the left mouse button and move ahead. Once it is done, click on OK. Just give it a name, okay, and click on OK. Okay, so this is how you digitize it. And after that, if you want to save this particular digitized file, go to save places as. Okay, save places as, you can save it as KMZ and KML, right? And you can open your KML files in QGIS, okay, as a vector file. Okay, so this is how I created all these files and I converted it into a geo package. Get our geo package in our workspace. Okay, so I'm going to select all these layers and click on add layers. Okay, and go to layers panel to zoom to layers. Okay, so this is where our these coastlines are. Okay, this is for 2024, 2009 to 1998 and 1985. Okay, so in order to remove any avoid any confusion, I'm just naming it from the it should start from the year. Sorry, rename it so that it doesn't confuses me every time. I'm just renaming it. Okay, and rename the layer. Okay, all right. Yeah, now let's see what is there inside the layers. Okay, so I have given it some date, some random date. Okay, so these dates are not correct, but I've just given it some random date. But this is not how you store your date in your this when you're working with this QSCAT plugin. Okay, so it will show you error later in this when you're using this plugin in the later part. So it's better we remove this date for now. Okay, so I realized it after sharing it with all of you, so I had to remove it before sharing, but let's do it now. You know how to delete some field, so just delete it, save it. Okay, okay, so this is what you require in your shoreline layers. Okay, so that was the first input that we wanted. Okay, these are the first input that we want. Now our next step will be to merge these layers. Okay, so let's first open our plugin. I'll click on this plugin here. Okay, just remove it, right? So it has got different tabs. Okay, and you have to start with the first tab, do it just in a sequence in which it is given. Okay, so select the CRS in which you are working. Okay, so the CRS for us will be 44 North. So this is your 44 North zone. You can give your affiliation if you want. I'll just put my name, affiliation. Let's keep it none. And let's give it some email. Okay. Just save it. These are not mandatory, but yeah, let's do it. I mean, why not? Okay. So next tab is our automator. Okay. So before going to automator, you need to merge all these coastline. Okay. So because here you see there is a shoreline field, but you have only one option to select it. Okay. So your shoreline layers should be merged together. Okay. So I'll go to my processing toolbox and I'll just type merged, merge vector layers. Okay. So you will find it in vector general tools, merge vector layers. Click on these three dots, select all your layers, click on OK, and designation, destination CRS will be 44 North, and save it to your file. Okay, and let's keep it here. Merged Shoreline. Okay, so name it very clearly because otherwise it is going to confuse you in your later sections. Okay, click on save, and after that click on run. Okay, so it is merged, and let's see this in our layers panel. Okay, so let's close all these layers because we do not need it now. Now our layers are merged. Okay, and if you open its attribute table, you will find it here. Okay, all the layers are merged together. Okay, now is the next input that you require is your baseline. Okay, so of course we have not defined our baseline. Okay, so I'm going to create some buffer around my merged coastline so that I can okay, and I'll keep my shoreline on the seaside, and I'm going to create the baseline buffer. Okay, so baseline buffer for my merged shoreline. Okay, and for a distance of, let's say, 500 meters, I'm going to use it. Okay, you can increase it or decrease it, whatever you want. Create buffer. Okay, so I have created this buffer around my shoreline. So this is 500 meters, towards the land, and 500 meters towards the sea. Okay, and as I said, I'm going to use this sea word as my baseline. Okay, but right now, if you will notice that it is it is covering the entire area, right? And it is a single line. Okay, but of course, this your starting point cannot be on two sides. Your starting point should be on the one side. Okay, so we have to break this feature so that we can delete all the unnecessary part. Okay, and before that, let's rename it as buffer, baseline buffer. Okay, just to avoid any confusion, and I'll refresh it to make it non-highlighted, and let's start our toggle editing mode. Okay, so let's delete all the extra thing that I have. So for that, I need to toggle the editing mode. Okay, and I also need this advanced digitizing toolbar. Okay, so this toolbar you will require, and how you do get that, you will get that here. Okay, in the advanced digitizing toolbar. In advanced digitizing toolbar, you need this split features option. Okay, split features option. So let's split this baseline because you see approximately my shoreline is ending, somewhere here. Okay, I'm not considering this part. That's not doesn't matter much. I'm assuming that all my shorelines are ending here. So I'm just going to split the baseline at this point. Okay. So what you have to do, left click and left click. Okay. Now you have made the cut, with on this baseline, and then right click anywhere. Okay. Anywhere on this screen. And let's see if we have splitted it or not. You see, we have splitted it. right? So this is how you do. And after selecting this, undesirable part, let's click on this delete selected button. Okay, and you see, still our this entire buffer is there. Okay, so we need to split it from this end as well. Okay, so let's split it from this end. You go to this again, you go to the split features option. Okay, left click and just cross the line that you want to cut. Okay, left click and then right click. Okay, you see it got splitted. Okay, and let's delete it. Let's delete the selected part. Okay, make sure the part you want to delete should be selected. Okay, otherwise the one you desire will get deleted. Okay, we have the baseline, we have all the merged shoreline. Okay, so these are the two to three requirements that we have for calculating these shoreline changes. Okay, so what else we require? Nothing. Okay, okay, fine. So next, in shoreline fields, as I said, we need a one layer that should have all the shorelines. Okay, so in shoreline fields, change it to merged shoreline. Okay, and these two fields are necessary in your merged shoreline layer. Okay, so make sure you check this date field name, uncertainty field name, QS date and QS uncertainty. You can rename it as you want. Okay, click on add fields. Okay, so your QS underscore uncertainty added and date is also added in your merged shoreline. Okay, so right click on it, open your attribute table. You see you do not have any values here. Okay, now you have to fill your values. For that, start this editing mode. Okay, and there is some defined format of date that you need to put here. Okay, for the format is your month, mm/ or oblique y. Okay, so this is the format that you have to follow. Let's say for 1985, I want to give it just month of May 05 and 1985. Okay, so this is the way you have to put your dates. Okay, no other formats will work. Okay, that will be all invalid. Just use this format. Okay, and let's say I want to go with 6 1998. Okay, and for 2009, let's say 7 2009, and for this again 7 2024. Okay, and this uncertainty is your the values in meters. Okay, how much plus minus you are uncertain about the digitization that you have done, or the layers or the shoreline shoreline digitization that you have created in your work. Okay, let's say for 1985 we have higher uncertainty. Okay, we are not sure whether the digitization that we have done or the data we have collected is quite good. Okay, so I'll start with 25 meters. Okay, plus minus 25 meters. And for 1998, of course, this value should be let's assume that it is a little lesser, and I'll go with 18. I'm just putting some random values here. Okay, but these values are in meters and you understand what uncertainty is. I'll give you some reason because of which this uncertainty arises. Okay, so your uncertainty, let's complete this first. Okay, and after that for 2009, I'm saying that I'm 10 meters plus minus uncertain about my shoreline. Okay, and let's keep it 5 meters. Let's keep very less for my 2024 because I just went to field and I collected the data. Okay, and okay, and after this you click on this save edits. Okay, and just switch this editing mode. Okay, so this is what you require in your merged shoreline layer. Okay, and close it. Right, so in the first tab you need to do all these things. Okay, in baseline fields you can do, but these are all your optional thing. Okay, you see it has given you optional. Okay, so with optional things, if you want, you can definitely go with it if you want, but otherwise if there is no optional written in front of it, then that means they all are mandatory. Okay, you have to perform all these steps. Okay, so uncertainty, yeah, uncertainty in your shoreline change can be caused by several factors, like let's say for image resolution. Okay, the data that we collected using your Google Earth imagery may have some resolution, right? Okay, because of which, let's say if it has 30 meters resolution, that means your data is anyway it is like 30 meters plus minus. Okay, and your image registration, for example, your image is not correctly georeferenced or correctly registered with the base image or with the reference image. And digitization, there can be some digitization errors, there can be tidal level positions, okay, which you are not certain about, and some elevation related issues, and let's say wind, or due to wind or wave action, sometimes you are not sure which point to take as your shoreline, okay, or which point you want to collect data from. All right, so these could be some of the reasons. Next, I hope this automator field is clear with all of you. Okay, so next is your shorelines. Okay, so now again you need your shoreline layers. Okay, so for shoreline layers you will go with this merged shoreline. Okay, it has invalid date, okay, QS date and QS uncertainty. Let me change this if it has some problems with this particular date now. Okay, so it has saved it, default data uncertainty. Let's keep it 25 meters. Okay, click on save. Okay, and after that you go to this baseline. Okay, so baseline is baseline buffer. Okay, and baseline I have created towards the, my placement is towards the sea. Okay, so that's why it's important that whether you keep your baseline towards the land or towards the sea. And now you have to check its orientation. Okay, if I will check the orientation, baseline orientation, then it will show me left and right. Okay, so now I can see my land is towards the right. Okay, so here you have to select the land is to the right. Okay, next click on save. Okay, and next tab is our transits. Okay, now we have to create some transits from baseline towards the towards our shorelines. Okay, so transit spacing, we will see what transit spacing is. Parameters is your transit length, it is meters. If you want to create for 2000 meters, or let's say for 1000 meters, it's all up to you. You can cast your transit. You see the transits are created, and now these are the perpendicular lines, of course. Okay, and now based on these transits your calculations will be done. Okay, so let's avoid this warning till at this point. Okay, I hope this all everything is clear. Click on save, and now comes our shoreline change analysis. Okay, for transits layer, okay, of course your transit layer will be the layer that you have created for transits. Okay, and what shoreline change statistics you want from this plugin. Okay, you can go with select and deselect all. Okay, but for now I'll just go with the shoreline change envelope, net shoreline movement, and endpoint rate. Now see, when we were in this shoreline change tab, okay, so shoreline change envelope, net shore movement, we will see what exactly these are. And maybe some people who are working in coastal and who are interested in this particular thing have some idea about, maybe good idea about these statistics. Okay, so you can compute your, let's compute our shoreline change, and we have all our stats. Okay, all our stats in our one layer. So these are your SCE. Okay, and you can see the trend accreting. Okay, and uncertainty, and the closest year. Okay, and the farthest year along that transit. Okay, along the transit, so this was the closest year and this was the farthest year. Okay, 1998 to 1985, it has calculated whether it is accreting or it is let's say it is okay, it's always accreting for SCE, and for NSM the trend is stable. Okay, net shoreline movement for is stable, accreting, or sometimes it is also eroding. Okay, and your EPR is stable and EPR trend is accreting. If you want, you can visualize that in the map. let's save it first. Okay, transit. Okay, and let's remove this. Let's see net shoreline movement. Okay, so you can give it different colors using the layer styling panel. Okay, for NSM layer, let's keep it categorized based on the NSM trend, classify it, remove it, and you see in this part, okay, you will see it is accreting, and it is always calculated between the farthest year and the closest year. Okay, so your shoreline change envelope, so it is a statistical technique that measures the total change in shoreline movement over time. It's the distance between the closest and the farthest shoreline at each transect. Okay, so for each transect that you see here, okay, so for each transect that you see here, you will find that you will get the difference between the closest year. Okay, so in along this transect, if it is the closest year and if it is the farthest year, it will calculate the distance or the net shore movement between the two. If this is the farthest year and this is the closest year, you will find the difference between these two. Okay, so next is your net shoreline movement. So again, here you have the oldest year distance and the newest year distance. Okay, and your EPR measures how much shoreline changes per year based on the net shoreline movement. It expressed in meters per year. To calculate NSM and EPR, you need only need the shoreline positions from the earliest and the latest years. So QSCAD will ignore any shoreline data from the years in between. This means it won't show how the shoreline moves during those in between years, even if you have that data. Okay, so that is, I think, the biggest drawback of this particular plugin. So however, you can use SCE to see the biggest changes and when they happen in the given time frame. Okay, so this is exactly what I hope this is clear what this NSM is all about. Okay, or what this SCE is all about. Okay, now your confidence interval is 99.70%, and here comes your area change. Okay, so for calculating the area, you need to cover all your shorelines into a polygon layer. Okay. Just a moment. I think I have to save this to the same projection system, which I didn't do before. Okay, and the shoreline change statistic layer that you need is your net shoreline movement for calculating the area. Okay, I'll remove this area from here. You can see This is your accreting shoreline, again within the highest tier and the lowest tier. Okay, and this is your eroding, and there will be some zones in which it is stable. Okay, let's see if we can find some stable zones. Yeah, you see here it is. Here your overall your shoreline is stable. Okay, in this particular section. Okay, even in this portion. Yeah. Okay, now comes your forecasting. Whether you want to forecast your data for forecast shoreline changes for 10 years or 20 years. Okay, transect layer, and your transect layer will be your transects. This is called Kalman filter that will help you in forecasting your shoreline change for 10 years or 20 years. Let's try. I'm going to revise all this thing. Okay, the correct thing that we have done. Okay, so this is your forecast points, forecast uncertainty points. You know how to visualize your data, right? You can go to layer styling panel at any point and just use these categorized or all these things to properly visualize your data. Okay, and there is visualization layer, shoreline change statistic layer that you want to see. Let's see, I want to see my net shoreline movement. Okay, and I want to see NSM uncertainty value. Let's say that is 25 meters. Okay, classification mode, let's keep it natural Jenks. Number of negative class, positive class, it's all up to you if you want to see. And let's remove everything that we have from here. Okay, and let's see how our results look like. Visualize, and this is our NSM visualization. Okay, if I zoom this to here, you see there are some portions of negative shoreline change movement. Okay, and there are some portions of positive shoreline change movement. Okay, positive means you're accreting, negative means it is eroding. Okay, so let's see. See, it is eroding, and you can compare it with the area change here. Okay, so this is how you can visualize. You can also visualize other statistics and keep it in your map. Okay, prepare your map for using it. You can save it, and if you want, you can also get your QSCAT summary reports. Okay, just click here, and here you will get the summary reports. Okay, you see, accreting areas, the total areas, percentage of areas, number of areas, average value, minimum, maximum values. Everything will be in meters, of course. Okay, so this is how you can use this particular plugin in your shoreline analysis. Okay, now comes, if you want to read more about it, if you want to if you are stuck somewhere within the plugin, first you can ask me. Definitely you can ask me, but if you want to work on your own, you have this user manual here. Okay, just go here, click on this. They have given everything in this user manual. This is very easy to use. Okay, yeah, you see, they have given you overview, from overview to your sample workflow. You can take the reference of how you can prepare the shoreline vectors and everything they have given in this particular, how your results should look like, step by step explanation on all these things. Okay,